In 8085 we have different kinds of the instructions which are used for the specific purpose, but there are certain instructions which seems to be working in a similar fashion but have different kinds of the operation after the execution of those instructions. So in this video we are going to discuss the what is the comparison in between the similar types of the instruction which which operates in a similar fashion but have some different kinds of execution. The first instruction to be compared is the sub A and MVI A00. Now, what is the meaning of sub A? It is going to subtract the content of accumulator with the content of accumulator. It means the accumulator content is being subtracted from itself, and whenever any digit is being subtracted from itself, the result will be 0. And the second instruction is MVI A00. The purpose of this instruction is to load 00 hexadecimal number into the accumulator. So meaning thereby sub A and MVI A00 results in a similar kind of value, and after executing sub A and MVI A00, the result will be, which will be available in accumulator, it will be 00. But we have to compare because the result is same but the working is different. So first of all, we have certain parameter based on which these two instructions are being compared. The first is the number of bytes. Subtract A instruction is a single byte instruction and MVI A00 is a 2 byte instruction. Now, as I told you, as far as the operations are concerned, sub A is going to subtract the content of accumulator with itself and the result will be 00, and MVI A00, what it will do, it will load 00 in the accumulator. So the resultant of both the instructions are 00. Now, as far as the addressing modes is concerned, subtract A is belongs to register addressing mode and MVI A belongs to immediate addressing mode. Now, we know that flags status are going to change whenever we do any kind of arithmetic or the logic operation. Since subtract A belongs to the arithmetic operation, so it is going to affect the for flags. But MVI A00 is a kind of instruction which comes under the category of data transfer instruction, so this is not going to affect any kind of flag. As far as T states are concerned, subtract A will be taking 4 T state and MVI A00 will be taking 7 T states, because 2 machine cycles will be involved in MVI A00 because it is a 2 byte instruction. So microprocessor has to fetch memory 2 times, read memory 2 times. That is why first memory cycle will be the opcode fetch and second memory cycle will be the memory read. But subtract A is the only opcode fetch operation. The second instruction which is to be compared is the sub B and compare B. Sub B is going to subtract the content of B register from the content of accumulator and the resultant will be stored in the accumulator. And compare B is a kind of a instruction which will be comparing the content of B register from the content of A register. Now, subtract B and compare B. Of course, it is going to subtract the content of B register from the accumulator, but as far as the number of instruction bytes are concerned, sub B is a 1 byte instruction and compare B is also a 1 byte instruction. Now, the operation of sub B is that it's going to subtract the content of register B from the accumulator and it will store the result in the accumulator. The instruction compare B is also going to subtract the content of register B from the accumulator content, but the content of accumulator is not going to change, as well as it is going to affect all kinds of flags, and depending upon the value of A and B, the flags will be affected. So as far as the result is concerned, the result will be A minus B, it will be stored in A, but in compare B, A minus B is done, but result is not stored in A and register A content will remain unchanged. Now, flag status are concerned, sub B is going to affect all kinds of flag and compare B is also going to affect all kinds of flags, since both the instructions is of single byte instruction. So both the instructions will be taking 4 T states. Machine cycle will be only opcode fetch in both the cases, and one is register addressing and another is also register addressing. There are certain similarity, but the functionality is little bit different. Now the third comparison is to be done in between the LXIH 2000 and LHLD 2000. LXIH 2000, it will going to upload 2000, means 16-bit 2000 2000H into the HL pair, and LHLD instruction is a kind of instruction by which we are trying to load the content of 2000 memory location address into the H register and 2001 content into the L register, like that. So there is a certain difference. Of course, it seems to be the same instruction, but one is loading directly the 2000 into HL pair, but another is loading the content of 2000 and 2001 in the HL pair. So LXIH is a 3-byte instruction, LHLD is also 3-byte instruction. The operation is LXIH, what it will be doing, the instruction loads the 2000 into the HL pair, and LHLD 2000, this instruction will load the content of 2000 memory location into the L register lower order and the content of 2001 into the H register. So the first one is addressing mode is the immediate addressing mode, the second one is the direct addressing mode. Flags, since both the instructions are direct data transfer instructions, so both the instructions are not going to affect any kind of flag. As far as T states are concerned, LXIH will be taking 10 T state because there will be 3 machine cycle, but LHLD 2000 will be taking 5 machine cycle and there will be 16 T states. Now we have to compare the instruction jump 2000 and PCHL. Jump 2000 is a indirect branching instruction. Whenever this instruction is executed, whatever is the sequence in which the program is being executed, whenever jump instruction is coming in between the program, it will jump to the 2000 location and it will start executing the 2000 memory address. PCHL is a kind of instruction which will be copying the content of HL pair into the program counter. So jump instruction is a 3-byte instruction, but PCHL is a single byte instruction. The operations are concerned, this jump instruction, this instruction is going to load 2000 into the program counter, so that next instruction which will be accessed and fetched and executed, that will start from the 2000. Now PCHL is the instruction which copies the content of HL pair into the program counter. So the processor fetches the next instruction from the address which is specified in the HL pair. So whatever is the content of HL pair, that will be copied in the program counter. So it depends that what is the content of HL pair, whatever it is, that a memory address will be fetched next time. Jump instruction is a direct addressing, PCHL is a indirect addressing. Flags, since both the instructions are data transfer instructions, so no effect on the flag. Since jump instruction is a 3-byte, so 3 machine cycles will be involved, so 10 T states, and PCHL is a indirect addressing, but only 1 byte instruction, so only 1 opcode fetch, but in this one opcode fetch cycle, it will be consuming 6 T states. Now the comparison between halt instruction and no operation. Both the instructions are single byte instruction. Halt instruction is going to stop all the operation, end, it is the kind of an end, and no operation is a kind of instruction by which a delay can be created, meaning thereby no operation is doing nothing, but halt operation is going to stop all the it is going to end the execution. But after no operation, there is a possibility that after some time the next instruction will be executed. So this is the difference. Now as far as the flag is concerned, though both the instructions are not going to affect any flag. As far as T state is required, in the halt instruction, T state required are undefined because this instruction is going to halt the processor, and the processor can be restarted by the valid reset signal or the interrupt signal. And no operation consumes 4 T state, and after this instruction the processor fetches the next instruction which is written after the no operation. Now the difference between call, return and the push and pop instruction. Now both the instructions belong to a certain category, which is these two set of instructions are a special category of the instruction. Call and return instructions are used for the execution of the subroutine, and push and pop instructions are used for the storing the register pair data temporarily into the memory. call instruction stores the address of the next instruction. Now it is the duty of the call instruction, because whatever instruction is written after the call instruction has to be executed, but it is not being executed, it is available in the program counter. It is the duty of the call instruction to store that program counter address somewhere in the memory in the form of a stack. So call instruction also involves the stack operation, but it is inherited within the call instruction. So call instruction store the address of the next instruction in the stack and the program counter, and loads the program counter with the address given within the instruction. Suppose it is written call 2070. So what will happen? It has to go to the address 2070, but before going to address 2070, it is the duty of the call instruction to store the previous program counter number, the address, into the stack. And push instruction works very similar in a simple fashion, that push instruction stores the content of the register pair into the stack. Similarly, the return instruction used to load the content of the stack which is already stored while it is shifting from the call main program to the subroutine. So that instruction, that address which is stored in the stack will be copied into the program counter, and pop instruction is used to retrieve the content of the stack into the register. Now these are the certain differences. Now as far as the similarities are concerned, both set of instruction use the stack memory. Call and push instruction decrements the stack pointer by 1, and read and pop instruction is going to increment the stack pointer by 2. And instruction, both the instructions are not going to affect any kind of flag. कहा उसी में तुम फ़ोन कर दी यार हमको तुरंत से, हम कह रहे हैं वीडियो बनाने जा रहे हैं, उसी फ़ोन कर दी, पता नहीं कहा आ करके बोल नहीं सकती थी।
सचिन को फोन करना था, हम ही कर दिए जवाब
क्या
मैसेज आया था कि भैया से बोल दीजिए एक बार सचिन को फोन कर दे कि हम मैसेज से आ रहे हैं, फोन नहीं उठा लो, कर दी
बोल दी।
हाँ लेटे थे, मन नहीं कर रहा था उठने का।
अरे ठीक है।